I'm Nicholas Cardo. I'm from CSCS. I work in the HPC operations group. And when I was putting together this presentation, I thought rather than say you can do it this way, you can do it that way, but to be more thought-provoking, to give you maybe some ideas or something to make you think about doing things a different way. So I went onto Wikipedia and I actually looked up what system monitoring is defined as. And I found this nice quote. And it's actually hitting it right on the head. When we monitor, we go out, we collect data, we analyze it, we store it, and then we report on it. That's the traditional model of monitoring. When I asked the question to several people, what is system monitoring? The most common response was detect system errors. Great, what does that mean? So I asked further, and I was given examples. And they were to detect device errors, file system full, file systems missing. These are just common answers, but this is so limiting as to what the capability of the tools actually can do for you. So looking at it this way, there is a lot more that we could be doing that we're not doing if we're just thinking in this model. So the first thing is to look at what a check actually is. We go out, we collect data, we analyze it, we report and record. Those are the basic steps, but that's a passive check. An example would be out of memory. You can easily detect an out of memory condition on a node, and you can easily report it. But why not take it one step further and take that passive check into an active check, meaning it will take an action automatically for you to correct the problem. In the case of an out of memory condition, pretty much your node is totally messed up and needs to be rebooted. So you can use Stoneth or something else and automatically reboot the node, automatically. No manual intervention. The great thing about doing active monitoring and correcting of problems is that you don't have to waste time. If this happens at 2 o'clock in the morning and your node goes out to lunch because it ran out of memory, and all you're going to do is reboot it, if you have to wait until 10 o'clock in the morning when you show up, then you've lost all those compute cycles. Whereas if you can automatically detect it, automatically correct it, then you've returned that node back to service with no manual intervention. So looking at this, you can divide system monitoring into 3 different categories. The first is what we commonly see as systems being monitored. Here you're looking for the state or the health of an actual compute system. This is just one piece of it. Our computers are getting much more complex these days. The computing centers are getting larger and more complex, but they all play an important role together. So the next part is monitoring the infrastructure. You're already hearing talks on having to monitor the network. Also, you have to monitor the facility itself for power and cooling. So that all has to come into play, as well as security of the machines. So we heard a little bit about that already, but all of this has to work together. When you hear the term system monitoring, you really want to take into account all 3 of these areas and build them into a viable solution for you. So system monitoring side, very common. You're looking for errors or abnormal operational conditions. Classic examples. Do I have all my file systems mounted? Is there free space on my Scratch file system? Is the system going idle? Right? We're all running some sort of a batch system to manage the compute pool of our clusters. Are they actually being used? Are we having excessive backlog for no reason at all? So it's kind of nice to know that your system's going idle before it becomes a problem and you waste too many cycles. Do you have failing devices? Typically, you can monitor the output from IBstat, and you can see if your InfiniBand network is having issues. Right? You can monitor if a link has dropped its speed, or even if you're getting a lot of transmit errors on network devices. And failed disks. This is an interesting one because disks fail in a variety of ways. Nowadays, with the smart technology on the drives, you can actually detect an impending disk failure. and you can take a proactive course of action. Same thing with memory DIMMs. You can monitor the correctable error count on a memory DIMM, and then you can schedule the node down and take corrective action before it fails and before it impacts your computational workload. So ideally, you're looking for the things that are not right with the system, anything that's abnormal. From the infrastructure side, commonly you can monitor your switches, your routers, and your subnet managers. Now you can have a good indication that you can communicate successfully between all the components of your center. A very important little piece there. You can have your cluster running ideally, fully operational, fully packed, but it can't communicate with storage. You have a problem. Inlet and outlet temperatures. Computers are getting bigger, faster, and hotter. So a lot of liquid cooling is now moving back into computer centers. Monitoring the temperature of the water going into your cabinets and coming out of the cabinets. You can compute the differential. You can see if there's a problem. If your outlet temperature is suddenly rising, you might want to look at what's going on. Do you have a problem with water flow? If you're not delivering enough water at the right temperature to your cabinet. Valve positions. Typically, these cabinets have a gate valve on them that will adjust automatically to control the flow of water based on demand of the cooling. What's the position? If you're running 100% open and your outlet temperature is continuing to rise, there's a problem. Power consumption down to the cabinets, chassis, even the nodes. Nowadays, with the new processors, you can get right down to the processor consuming power, as well as the memory components. An interesting thing there is, a week and a half ago, we just detected a problem on the Cray system because it was noted that one of the modules, the blades inside the Cray, was actually consuming more power than the power capping. So that's an indication. We had no clue that was even happening. We stumbled on this. Now we're putting it in as a check to see if we have an issue. So that module's been removed and is being repaired. But it's just an indicator, something that you wouldn't think to monitor is the power consumption. But it's a very simple test, and it can be very important. Security is an interesting one. Everyone would think security is off on the side doing its own thing. You don't have to build that into your system monitor. But there are things you can do very simply as monitoring your system that can detect problems. So the first one, we've never seen Etsy Shadow get set to read-write, right? But we all know how bad that is. How easy of a check is it just to monitor the permission bits on that file and see if it changes? If it turns to read-write, there's something wrong on that node very seriously. You can look inside history files. Very easy thing to do. You can see things like somebody going after dev kmem for no reason at all, and you can flag it and maybe look into it a little further. Exploits are published. Even the fingerprint of an exploit you can identify and locate. You can build that into a monitoring script and actually look through everyone's history and see if you notice that pattern. Unexpected system changes. If you're running a production configuration, your system should only change when you change it. Classic things to look for, the size and date stamps on directories like user sbin. What do hackers like to do? They like to replace your SSH binaries and then put backdoors in to collect all sorts of passwords and usernames. How would you know that happened? Well, if the directory got modified or if the file count changed in the directory. These are just little things you can do to better protect yourself, but build into your system monitoring infrastructure. Detect privilege escalation. Everyone is capturing their auth log. How many people are actually looking at that through an automated method? Periodically, your security analyst probably goes through it and says, oh yeah, this is all normal. Well, if he's looking at it, it's already too late. Why not have something sitting there monitoring that and looking for escalations of privilege by people who shouldn't be? It's a very easy thing to do. There are a lot of tools out there. A lot of them generally available. Nagios is probably the most popular out there right now, and it's freely available, but it has its limitations and it has its quirks. It's a very chatty monitoring system. Every event has to be acknowledged. It gets notified that it's acknowledged, then it clears, it gets acknowledged. You know, lots of emails can be sent from Nagios. But it is an effective tool if you use it and if you build it into your own monitoring model. Big Brother is another one that's out there. It's just looking at things, looking for changes. Bro is a security. It's an active security intrusion detection system. So it's sniffing packets, looking for patterns, taking actions. If it detects something anomalous, it will actually throw blocks into routers and switches. So it can take action. It's an active check rather than just being a passive monitoring check. Puppet and CF Engine are configuration management tools. They're also very effective for monitoring your machine. If you're familiar with a Cray, it uses a shared root environment that is read-only on all the machines, on all the nodes. So it can't be modified. That kind of makes configuration management tools like Puppet and CF Engine inefficient or ineffective. But you can use it to monitor. I can easily put together some Puppet modules or a CF file for CF Engine to go out and monitor files, monitor configuration files. It can monitor checksums. So you can set this up to be very powerful as a monitoring agent on your machine. And then you can tie it in to whatever infrastructure you have. I highlight the last one there, What's Up Gold. You can actually buy tools to do this for you. And that's just one of them there. There's provisioning systems. We all know XCAT, Perseus. Last one is Bright Cluster Manager. It's one that you would have to buy. But they're building into these things monitoring capability and the ability to process logs. How many people are actually looking at the logs from XCAT or Perseus and seeing who's been changing what? If you're a bad guy getting into one of these management servers, what's the first thing you're going to do? You're going to modify an image so that the next time it gets booted, you have the machine. Right? If we're not monitoring for this, we're not going to catch it until after the damage is done. Log analysis, I put two of them there. Splunk, we're all familiar with Splunk, and Graylog. Well, Graylog is a version of Splunk. It's an open source version that does about 3/4 of what Splunk can do. So if you're impacted by budget, Graylog is a great alternative. You just send it there, you identify the patterns, it flags them, and it notifies you. Well, if it can notify you, it can take an action. So think of it that way. And then there's homegrown. Everyone has a check script that runs on a machine, right? You're looking for problems. You want to make sure that the machine has booted correctly. Well, you can build that into your monitoring capabilities. If you can run something very quickly that can check a machine to see that it's healthy enough to run jobs, why can't you periodically run that and tie that into your system monitoring strategy? At that point, you now can monitor everything. And there's just two there that are homegrown. I put the title of this one, Work Smarter, Not Longer. Clusters are getting bigger. When I first started in this industry, you would get a single box about yo big, and that was your computer. Now that little box fits on your wrist, and you're now managing hundreds and thousands of nodes in a cluster, and you can't do it by hand anymore. You have to automate. So by working smarter, It's taking advantage of the tools that you have in order to do all this without the overhead of the people. So you're staffing. If you're growing your computers, are you growing your staff? Pretty much no. But if you're just extending a machine, why can't you just extend the monitoring capabilities? If you build into your center a very effective monitoring capability, then taking on new nodes in a computer is just a matter of a few moments of adding them to your configuration. Converting from passive to active checks also reduces the impact on staff. If you can take 50% of your interrupts and automatically handle them without manual intervention, you've just freed up your staff to do more work. A problem that I see all too often is centers go out and they write a system monitoring script or a check script. And I've seen some of these that are 15 and 20,000 lines long. The problem is they're very hard to maintain. When they get that big, you can change something in one area, but it affects everything in the entire script. They break very easily. They're difficult to modify. People become afraid to even adjust them, tweak them, add a new check because of what can go wrong. And then when it does break, how long is it going to take you to fix it? So a caution there is not to make them too big. They need to be manageable and maintainable. And don't look at a single tool. I've been in computer centers where they swear by Nagios, or they swear by Perseus, or they swear by what their tool is. But they don't look at the other options available to them. And so their capabilities are limited to just what that tool can do. If you look across the board, you can combine tools into an effective model and do so much more. And the last comment on this one is design the solution, don't squeeze it in. You have a lot you want to do, and if you have one tool, you're going to try and make what you want to do fit into the tool, even if the tool is the wrong one for the job. So use the right tool for the right job. You want to design this carefully. Find out what tools are available to do what you want. If you need to look at open source solutions, fantastic. There's plenty of them to choose from. If you have a wealth of money in your budget and you want to buy commercially available solutions, fantastic. Choose the one that works best for you. Custom tools are a necessity. What you can get from the network, download or buy, will not do everything you want. So you always need to look at that as a possibility or a necessity. So when necessary, write what you need. Don't use a single tool. Combine them. Take a look at what you have to monitor, what you're looking for, your center, and say, okay, I can use this tool to do this, I can use this tool to do this, I can use this tool to do this, and apply it to the center. Build a model that you can actually work with to give you what you need. There's a quote from Sir Henry Royce that says, don't accept anything nearly good enough. So go out and actually do something, make it better. Unify. Don't look at it as a tool for this, a tool for that, a tool for that. Build a single solution that uses all these tools. The last one is important. A lot of people write this stuff, put it out there, and never maintain it. They assume it's going to work forever. Staff moves on, and then something breaks, and then you have to reinvent it all over again. So make sure you build a support infrastructure for it. And that's the last thing.